Git and our Jenkins tool as we done as we going through our DevOps cycle. So first part it was like our Git, like pushing the code to our Git repository or managing our code versions and creating release or creating branches. So I think you guys are like know about like how to do things now. So then we completed also Jenkins, and in Jenkins we completed the creation of a job or creation of the credentials or like creating another job through like the previous job. So we have completed all the process. So till now we have completed Git and Jenkins. So from now we'll be knowing this part of our Jenkins. This is the main part. Like it will be like after your code is created and pushed to GitHub. So now you need like, let's say you have 10 to 20 developers. You want to build the project. So for this we need a tool called as Docker. Okay. So today we'll be going through Docker and we'll be knowing like how Docker is helpful to us and how previously we are facing the issue and how it solves our problems. So let's start. Okay. Yeah. So Docker is nothing but a containerization tool. Okay. So before going into containerization, what is containerization and how it is implemented, we should know like the previous approach, how was the code was generated and how it is built and how it is put into a production environment. So if you'll see here, so I have written all these things through points. So first point it says as the traditional application of building a process, like building an application. Okay. So there are multiple developers will write our code. Let's say Python application we have taken. So they will be using some different libraries. Let's say backend developer will be using some different libraries, and the database guys will be using some different libraries. So they will all things will be now pushed into our Git repo. Okay. From there, what you will do, you will take that code, you will package it manually through the Python build stage. Okay. So then building means nothing but you will taking the libraries, dependencies, or the configuration of settings of this Python application that you are creating now. You're putting all things into one package that is called as a application build. Okay. And then what you'll do, then you'll take your environment, let's say your that dev environment or production or staging environments. Let's say it's a virtual machine. So what you will do, you'll transfer these build files to there. Okay, those environments. Then manually you will go and install the operating system there. Let's say all of our production grade environments will be running on Linux. Okay, so there you need to install a Python and the dependencies that you will be using in your Python application. Those things you need to install. Then you need to install Git also because you need to fetch the changes from your GitHub. So you'll all things need to be done manually before. These are all things. Let's say tomorrow if you want to create one new build of your Python application, then what you will, you'll go manually push the code to the your Git. Then you will again build the application. Then there will be like let's say some issues. Let's say you are person one, but the person two or the developer two has created some different changes to that application. Okay, but those changes were not be reflecting because of some mismatch in the configuration or the independency. There it will be. So due to that, the application build will get failure every time. Okay, so this is what I mentioned in a third point. That's the problem what we faced due to these above stages we are doing previously. Okay, so let's say our developer is using his Mac OS or Windows. Let's say Linux also for the coding. Okay, but a production environment is running on different OS. Okay, so what it will be? So let's say if you are writing the code to be running in your Mac OS or in your Windows or Linux, it will using some different OS packages to run that application. Okay, so it means that your code is dependent on your OS operating system package to run. Okay, that's a big problem. Like there will be, it's a famous word. It's saying in the IT world that it works on my laptop but not in the production. Okay, so to solve this all the problems that we are getting now, program like the version mismatch or the library mismatch between the developers or between the developer environments means your laptop with the production environment. So to solve this all issue, the concept come as containerization. Okay, so this containerization is nothing but it's a tool. Okay, it's a concept actually. from this concept we created one tool is created that is called as Docker, which do all of the things that I'll be going to tell. Okay. So first of all, what we'll do, we have a Docker file. It's nothing but just a file that is saying like what your application will be using as a operating system, the base OS. Okay. Like it will be a common operating system that you will be using to your run your application. Let's say in your Windows or your Mac OS or in the production Linux environments, you will be using those. And this all will have the same library versions, dependency versions, and same configuration what will be running in your own local environment or in your production environment. Okay. This Docker file is used to build your Docker image. Okay, that I'll make you understand like what things will be doing. Okay. So it's simply a lightweight, standalone, executable package, like what we call as build. No, this is what. Okay, a Docker file, you write what are things you need to build. Then Docker image is that build after the creation of the after what your application needs. Let's say your library and these all dependencies. Okay, everything need to be run in an application. That's what a Docker image is. Okay. So then what you will do, it's we have this Docker engine. Okay, that is called nothing but a container runtime. Okay, so what it will take that image and it will run in an environment, and it will start your application and expose your application to the internet or where you want to expose it. Okay, it's just three simple steps that you need to do. So here what it will do, no manual dependency setup you need to do on the target environment. So manually we before we have no, I told OS dependency will be there, or let's say library mismatch will be there, library versions mismatch will be there, or configuration mismatch will be there. Let's say some other developer using some different configuration, you are using different configuration, so error will be there. So these things are now removed from this using this Docker. Okay. So if you'll see this image, so this is what a Docker workflow will be looking like. We'll have this Docker file that I'll tell you later what things need to be done inside. Like just for a overview, it will have the operating system or what things your application need to be running, which version. Let's say if Python need to be using this any of the data pipeline, data libraries or like that. It need to be using. So that time you will be giving its versions and everything mentioning in this Docker file. Okay. Then when you will trigger a command to build that file, then it will create one like shareable image. So the image is nothing but a build of this file. Okay. So this build you can take and run it any Docker where a Docker container runtime is running. No, you can take this image and run it there as an application. Okay, and simply expose it to your other world. Okay, and you can use this. Then yeah, then as I told, let's say your then when you need some code changes, developer rebuild the Docker image with just a single command. So before what you are doing, I was telling, you know, if you change some code to Git, then it will go to, you will manually create the build, then you will push it the new build to the new environment again, pull the all the libraries there again, check like all the dependencies are same or not. Okay, you need to check all those things manually, but here what you are doing normally in your Docker environments in your own Windows or Mac OS you are using. So what you will do, it like the Docker file, you Docker create one image, so you, that image you can share anywhere to any operating system or production environment also, same thing. It will use the same dependency, same versions and everything same. So the all the issues are now gone. Okay, using this. So the new image is deployed universally across all the environments without any modification. Eliminates environment specific errors and manual tweaking. Okay. So these all things are now gone. So now you understand like what is Docker image and what is a Docker container. Okay. So now you need to understand this Docker engine. So what is this Docker engine? Where it is running? Okay. So for that, you need to understand first what is a virtual machine and what is a Dockerized environment. Okay, or Docker container, or let's say Docker architecture, anything you can call it. Okay. So before what, no, virtual machine means like if you will have a infra or you let's say your own laptop. it will have some operating system, let's say Windows. So on that top of that, you will be using a software called as hypervisor. Okay, it's provided by many companies. There will be Oracle hypervisors, VMware hypervisors, they will be providing. So what these hypervisors will do, they will take your infrastructure or your laptop's environment, like say RAM or CPU cores. They will logically divide them into vCPUs, or their logical RAM separation, let's say 1 GB, 2 GB. Like they will separate your logically your RAM or your core VPC cores, and they will use these to run one application or separate logical isolation from your current operating system that is running on your laptop or your environment. Okay, so it will be totally isolated from what you are using in your like host OS. Okay, so it will have your own operating system like guest OS. It will have, let's say, this is your Windows. Okay, but here you can run your Linux, here you can run Mac OS, here you can run some Linux different versions. Okay, so different thing will be, it will be separated from each other. Okay, means these two cannot be talk to each other, these two cannot talk to each other. You can do it, but it's not how the VM works. Okay, so it's called as virtualized environment. Okay, so now comes to our Docker environment. So Docker, the same thing will be there, our operating system, let's say Windows, but in like except of the hypervisor, we'll be using a Docker engine. Okay, so Docker engine is what, it will take the host kernel. Okay, in operating system we have a concept called as kernels. So kernel is nothing but what the actual package that will help your application to connect with the hardwares. If you want to do some hardware changes or anything like that through logically, so the kernel used to talk with your hardware and give the output or input with that your infrastructure. Okay, so what application you'll be running in this container or this virtualized environment, no? So it will be using the same operating system host, same kernel as of your host OS. Okay, by this, no, what happens, the this environment will take very less RAM, very less space to run your application. And this in one problem is there in virtualized environment, that's so called as when your application, let's say your virtual machine have some error, some issues you get. So what you will do, you'll go delete it and again create it. No, it will take around 5 to 10 minutes. I'm telling about a 2 GB RAM or 3 GB RAM virtual machine, not about 100 GB. 100 GB means it will be taking more than one like half an hour, 15 minutes to half an hour. But here if you'll do the same thing, no, it will take you just 1 to 2 minutes. For I'm telling about 50 to 100 GB RAM you are doing. For 1 2 GB RAM, it will take within seconds to start one application and run it. Okay, here you need to do many configuration. You don't have something like Docker file. Here we have, oh, we'll mention like these things will be there, these things will be there. Here the same, we'll be going inside and creating again dependencies and creating operating system, and all things we'll be doing here. Okay, but here everything is written in our Docker file. Now it is running, we build it to a image, then we are running it on a Docker engine. Okay, it's creating very simpler way to our application to be exposed. Okay, so now you got to know what is the difference between a virtual machine and your Docker environment. Okay, so next thing that we need to learn is Docker architecture. Means like Docker, how it looks like, how it is working inside. Okay, so Docker has these three concepts. It's called Docker client, Docker host, and the registry. Okay, so Docker client is nothing but your Docker CLI. Means it's a CLI tool, same as your PowerShell, same as your like macOS shell. Okay, so you can use this shell command to do something in your Docker environment, or this is Docker host means Docker engine, simply Docker engine. Okay, you need to create a container, you want to build a image out of your Docker file. These steps I told, no, to Docker file to Docker image, Docker run. Okay, these all things you can do it here using your this CLI command. To it will tell to a Docker daemon that will be running in your Docker engine or your host operating system. Okay, so it will create build means that I told, no, from image to from a Docker file to image. Okay, means it will create one image out of it, and then if you run this command docker run that image name, then it will run that container as a application. Okay, so you understand now what is docker host, docker client. Then you need to understand this point also, registry. Okay, so docker registry is nothing but a simply we have this git and github, no? So we write our application in our local, but we post into an some registry, or you can call it at github where you push your code. So same after we build our application, our image is created, we can push it to a registry from where the other developers, let's say another developer too will be here, he will be having this docker host in his own environment. He can pull this image, let's say this command he runs, and he'll pull and run these images in his local environment. Okay, so it will be like no, it will be not depending on the OS that he will be using. It will be just running on top of his operating system in Docker daemon. That's what all about Docker concepts. Okay, architecture, like how this is running, how this flow. You need to understand more clear way how this flow is going on. Okay, then we know about now virtual machine and Docker architecture differentiation. How previously we are doing our application deployment, what problems we face, then how we like standardize the things and create one Docker environment. Okay, so now you got to know about how the Docker works. Okay, so first of all, you can go to Docker website to install this. Okay, Docker installation. Okay, so you can get it from here. Okay, let's say if you are running install on any of the environments, now you can run it anywhere. Okay, so you need to check on where you need to install this. It, let's say you are using Mac OS or Windows, so you can do likewise. Okay, so but for now you can it's a best way you should have installed this Docker, and you try to use that one. Well, I'll next class I'll tell you about the Docker file and your Docker engine, how it is working internally to build. Okay, so it's a separate topic, but for now you try to install this Docker in your own environment. And if you don't want to install, if you're facing some issues in your hardware configuration, or it will be as Docker engine also it taking some spaces now, it will it can slow down your computer if you have like less than 8 GB of RAM. Okay, so for that time you can use this Docker tutorial page. You can go to this docker.com /101 hyphen tutorial. Okay, so here you will find this play with Docker. So here you can go, then you can start. So it's a free version online. They're giving some environments to learn about this Docker environment. Okay, how you can run this Docker client commands, Docker build, pull, run. There are many other commands also you can run with Docker. Okay, so how you can all these things you can do? You can like create one instance here, and you can do practice it here. Okay, so so this is all about today. So you know about now Docker and how we'll be doing the things. So okay, so next we'll be learning how to create a Docker file, then creating a image out of it, then and then save the image to a Docker registry and pull and run in a different environment. Okay. So then again, and at last we'll be integrating this Docker to our Jenkins, what we have learned. Okay. So this is all about it today. So see you in next class. Thank you guys.